In continuation with the construction of a cycloid, in this particular session, we will see the construction of an epicycloid. An epicycloid is nothing but a curve generated by a point on the circumference of a generating circle when it rolls on another circle outside it. And the epicycloid we can obtain in the similar way as the points which we have discussed in the construction of cycloid. But here in epicycloid, instead of directing line, we are considering a directing circle on which the generating circle will rolls without slipping and sliding. So what is epicycloid? So epicycloid is a path traced out by a point of the circumference of a generating circle when it rolls on another circle without sliding and slipping. So here you can see that the green circle is nothing but a generating circle which rolls on a blue circle, which is the directing circle. And the path traced out by a point P or any point on the circumference of a generating circle, this red line is nothing but an epicycloid. The epicycloids are used to design the gear tooth profile. Now we know that an epicycloid is the curve generated by a point on the circumference. Say here is the point P on the circumference of the generating circle. Circle. Okay. When this generating circle rolls on the, this is the portion of directing circle. Circle. When this generating circle of say diameter small d rolls over the directing circle of diameter say capital D, okay, then the path traced out by any point on the circumference of generating circle, that is say P, okay, is known as the epicycloid. So this curve is known as the epicycloid. Now the circumference of the generating circle is pi into d. Now when this generating circle complete one revolution around the directing circle, the arc length which is covered on the directing circle is equal to same as the circumference of the generating circle. And the radius of this directing circle, that will be capital D by 2. Now we need to find out how much angle covered by the generating circle for its one complete revolution. Okay, this is the required parameter needs to be calculated first to complete the construction of an epicycloid. So we know the formula that L equal to r theta. Well, L is nothing but the arc length. So here arc length is the pi into d. Okay, this one is the arc length. Radius is the radius of the arc, that is capital D by 2, and theta is the included angle. So theta we can estimate as 2 pi 2 pi small d by capital D. In angle it is 360 into Small d is nothing but the diameter of the generating circle divided by capital D. That is nothing but the diameter of the directing circle. So this formula is important to estimate the theta which is covered by the generating circle when it rolls on the directing circle of diameter capital D. So for the construction of the epicycloid, as a first step, we need to calculate the theta first. Now we will see the construction procedure of an epicycloid step by step. So once the theta is calculated, one can start the construction procedure. As a first step, we need to draw the portion of the directing circle. Okay, and here this angle, included angle, is the theta. So this angle is the angle theta. This arc is nothing but the portion of the directing circle. So now we have to draw a generating circle first of say given diameter small d. So draw generating circle of diameter d. Okay. Divide this generating circle into 8 equal parts. As so the contact point is the reference point which is considered for the construction of an epicycloid. So as the circle rolls on the directing circle, the point P will move in the anticlockwise direction. So the numbering is also done in the same direction. 1, 2, 3, 4, 5, 6, 7, 8. The point P is the reference point which is considered to construct the epicycloid. So in the next step, draw the locus of center C. Here center C is nothing but the center of the generating circle and divide that into 8 equal parts. So the locus of center C will be an arc which is parallel to the directing circle. So draw the locus of center C and divide this locus of center C into 8 equal parts. So here we need to divide this angle theta into 8 equal parts. So we can obtain the different positions of the center C when the generating circle rolls along on the directing circle. So C1, C2, C3, C4 are nothing but the different positions of the center points when the generating circle rolls on the directing circle. Now we know the procedure which is similar to the uh, cycloid. Okay, so draw arc from 1, 2, 3, 4, 5, 6, 7 and point 8. Okay, now consider the rolling of the generating circle along the directing circle. Now consider the rolling of a generating circle surface of the directing circle. So as the rolling starts and point C, that is the center of initial position of the center of the generating circle, approaches to C1, means the new position of the generating circle at C1, we can obtain the point P1, that is nothing but the position of initial point P. The new position of point P1 can be obtained by considering C1 as a center and drawing an arc of radius equal to radius of generating circle, that is nothing but d by 2 on the arc passing through point P1. So C1 as a center, arc of radius equal to d by 2 on the arc passing through point 1. So that will be the new position of point P when circle is at center C1. Okay. Now continue with the same procedure and obtain the different positions of point P when the circle reaches to the different positions C1, C2, C3, C4, C5, C6, C7 and C8. Similar way, P2 can be obtained by considering C2 as a center and radius equal to d by 2 and considering the arc on arc passing through point 2. Right? So on arc passing through point 2, we will get the point P2. Okay. Now consider the third position of the generating circle at C3. So C3 as center, d by 2 as radius, and considering arc on arc passing through point 3, so we will get P3. Similar way P4 can be obtained. Okay, so point P4 is the highest position of the or the topmost position of the epicycloid, where the point P reaches to the position of point 4 during its rolling condition. Okay. So P4 can be obtained. Now C5 as a center, d by 2 as a radius, considering arc on arc passing through point 5. So we can have the P5. Same way C6, P6 we can obtain C7 as a center, and we can obtain the P7. And at last, after completion of one revolution, point P will get its original position, that is the lowermost position on the circumference. So we can obtain the P8. So once P1, P2, P3, P4, P5, P6, P7 and P8 are obtained, to obtain the epicycloid, we need to join these all this point P, P1, P2, P3, P4, P5, P6, P7, P8 by smooth curve. So this curve is nothing but an epicycloid. So the curve obtained is nothing but epicycloid. So the construction procedure is same as the construction of a cycloid. In case of cycloid, the generating circle is rolling on a straight line, that is directing line, while in case of the epicycloid, the generating circle rolls on the another circle and outside of it. That another circle is nothing but a directing circle. So in the next step, we will see how to draw a normal and tangent at any point on the epicycloid. Say that point is point S. So mark as per given condition, mark point S on epicycloid. So from point S, draw an arc of radius equal to d by 2 on locus of point C, that is center point C. So this radius is equal to d by 2. Draw an arc. We can obtain the point CS. Now from this point CS, draw a radial line, okay, which is passing through the center of the directing circle. And we can obtain the point N on the portion of the directing circle. Now draw a line passing through N and S, that will be the normal NN, and we know that tangent is nothing but the line perpendicular to the normal and passing through point S. So from point S, draw another line perpendicular to normal NN, that will give you the tangent, that is TT. So this is the complete procedure of construction of an epicycloid and to draw a normal and tangent at any given point S on the epicycloid. I hope the construction procedure or construction of an epicycloid as well as the procedure to draw normal and tangent at any given point S on the epicycloid is clear.